So, practical application of using SOHCAHTOA, sine, cosine, tangent, and their reciprocals. So we have a problem here. Wind speed affects the angle at which a kite flies. The table at the right shows the angle the kite line makes with the line parallel to the ground for several different wind speeds. Okay, so we have the kite flying, we have the table at the right, the angle, we have the angle that the kite makes with the ground. There we go. For several different wind speeds. You are flying the kite, so this is you. Here's you. You have a hat on. There you go. You're holding your kite. There's you. There you are. You are standing 4 feet above the ground using 500 line. There you're holding. You're using 500 feet of line. At what altitude? So here's your A. What altitude? That's what you're going to figure out. Is the kite flying if the wind speed that day is 35 miles per hour? So let's go over to our chart. The wind speed for our day is 35 miles an hour. We want to find A. Our angle, if that is the case, then our angle is 45 degrees. Because look at what our question says. That shows the angle the kite line makes with the line parallel to the ground. Okay, the parallel to the ground, so 45-degree angle. So we need to find A. So what do we have? We have an angle, we want the opposite side, and we know the hypotenuse. So what are we going to use? We're going to use sine. So the sine of 45 degrees is equal to A, which we don't know, over opposite over hypotenuse, which we do know. Okay, so we use the ratios involved that we want. So what are we going to do? We're going to take our calculator. Okay, Mama. I'm going to cover this up for just a moment. Turn it on. And then we're going to make sure, what's the first thing we make sure? We make sure we are in degree mode because we have the sine of 45 degrees. We are in degree mode. Please check that first, okay? So second quit, we're going to say the sine of 45 degrees. Enter. So that is 0.707, 0.7071, where 0.707 is equal to A over 500. Now, because I have ratios here, I'm going to set this up and solve it according to ratios. I like to make sure I have equal ratios. So I'm going to put that over 1. I can put anything over 1. And I'm going to solve it by cross multiplying and dividing. So I have this A times 1 is A is equal to, cross multiply, 0.707 times 500. So I'm just going to do that on my calculator. 0.707, etc. times 500 is 353.5. A is then equal to 353.5, and what units are we at? We're at feet, right? Feet. Okay, so at what altitude is the kite flying? If the wind speed is 35, the kite is flying at an altitude of 353.5 feet. All right, let's go on to the next problem. It's a little more complicated. This is what the hardest part about this is, reading and knowing what you have. An airplane is flying at an altitude of 30,000 feet, heading toward the airport. To guide the airplane to a safe landing, the airport's landing system sends radar signals, so the airport is sending radar signals this way, to the runway from the airplane at an angle of elevation. Angle of elevation always means upward. So this is our angle of elevation at a 10-degree angle. So this is 10-degree angle. How far is the airplane measured along the ground? So this is what I'm looking for, X, from the airport runway. Okay? And we note that 1 mile, they've given us feet, but they want the answer in miles. So we have this conversion. 1 mile is 5,280 feet. Okay, we want this X. How many miles are we away? We want that in miles. Okay. So what are we going to do? Well, I obviously can use trig ratios to figure this out. So I have a 10-degree angle, I have an opposite, and I want the adjacent side. So what does that say to us? Well, that says to me tangent or cotangent. So let's solve with the tangent. I have the tangent of 10 degrees is equal to what? 30,000 feet over x. Sorry, I started to write something else. X. So I'm going to take my calculator. I know it's already in degree mode, and I'm going to say, what is the tangent of 10 degrees? And I get 0.1763. So 0.1763 is equal to 30,000. I know it's in feet over x. Setting up a ratio, I'm going to put that over 1. I'm going to cross multiply. I'm going to get 30,000 is equal to 0.1763x. Solving for x, I'm going to divide both sides by 0.1763. 0.1763. These cancel, leaving me with x is equal to, let's just divide that out, 30,000 divided by 0.1763. Do that on your calculator. Okay, so you put that in the light. You're just dividing that. You get 170,164.5. But that's in what? Feet. Okay, I know that's 1 feet. I don't want it in feet, I want it in miles, so I have one more step to go. So I have to do a conversion. So I take 164.5 feet, and they've given us the conversion. So when I do conversions, I have 1 mile for every 5,280 feet. So what do? 1 mile for every feet. So I divide this many feet by this many miles, right? Cancel out the feet, and that will leave me with miles. So I take that many feet divided by 5,280 feet per mile to leave me with 32.2 miles. And that is my final answer to answer the question, how far is the airplane measured along the ground from the airport runway? So 32.2 miles. And there's my final answer. And you see what we've done today. We've been able to use trigonometric ratios, tangent and sine, to be able to figure out the side lengths of not just triangles, but real world situations. Okay, there we go.